Hey, and we are live again with, what are we doing today? The .NET Language and Runtime Stand-Up, that's what we are doing. So let's just introduce ourselves again.
So my name is Ahson. I'm a developer at the .NET BCL team working on .NET Core.
So that's how you pronounce your name. I think I've always done it the wrong way. So my name is Emil Landruf. I'm a PM on the .NET platform team.
My name is Philip Carter, and I do stuff with F# and other .NET things.
And he just made me at least 5 years older. Like, he was hiding in the corner when I came into the room, he yelled at me, and I'm still recovering slowly from this exercise. So today what we're going to do, we want to talk a little bit about our new JSON APIs. So there's a blog post coming later today. We're still in the weeds of tweaking it a little bit because WordPress, but we will hopefully get it out in time. That should be possible. We also have a video recording with more demos, but this is a perfect opportunity for you to ask us questions about the new JSON APIs, why we built them, and whatnot. So maybe I don't know, what do you want to talk about today?
Just a few things related to F#.
Do you have anything prepared, like slides or?
No slides.
No slides?
Just a few things.
Just a few things. Because you don't have a connection, so you can just talk to it. You can just talk to it?
Yeah.
Then just talk to it.
Okay.
And do this in this radio voice, please.
Sure. Yeah, so there are kind of two, there's been a lot of F# things happening, but sort of two prominent ones, I guess, to call out. Is F# for Visual Studio Code via the inide plugin is churning along quite a bit. It's heading towards a 4.0 release with a lot of different changes, especially as it relates to performance improvements and fully implementing language server protocol. And looks like it's going to be pretty great. It's set for, at least we're intending, at least working with the open source people who work on it, sort of planning with them, okay, kind of by the end of this month, we're thinking an inide 4.0 release sort of makes sense. With that, yeah, there's just going to be tons and tons of performance improvements with F# and Visual Studio Code, and like a bit more of a getting started experience that's more tailored towards .NET Core, making that just nicer as a whole. And that should be pretty good. The second one is, it's something that is now finished, but there was a thing called the Applied F# Challenge this year. It was sort of a call to the F# community to be like, hey, for all the different domains that you use F# in, like, create an application that does so, or write an article or something like that. And, we had a couple of expert F# users sort of act as judges for different categories. And so the winners were announced a while ago. And so there's some pretty cool ones. Like, let's see, one of them was a Cloudflare workers in F#. So this is, Cloudflare is, it's sort of like Azure Functions or AWS Lambda, except for, Cloudflare, I think. Yeah, Cloudflare is the name of the company. I keep forgetting it's that. But anyways, it uses Chrome V8, but it does like all sorts of, it does things very, very differently. And so somebody was like, hey, I wonder if I can get F# to work on that. And turns out they did. So pretty cool, right? And there were also some pretty cool ones, like a guy who does signal processing wrote like a really cool thing about how you can use F# for signal processing work. And there's also a really cool one called Applied Metaprogramming with Myriad and Phalanx by Dave Thomas, it's a massive blog post that he wrote that sort of said, like, hey, if you thought you could do metaprogramming with F#, well, let me tell you how you can do it even more. And it's pretty cool. So I recommend everybody sort of just look up the F# Applied Challenge and the results, because the results, there's just a lot of really, really cool blogs and a really cool set of projects in there. Yeah, I think another one that was really cool, which is a FSH, an F# shell with integrated F# scripting. So rather than requiring bash, you can actually use F# to sort of script your stuff. So that one is also pretty sweet. So yeah, I recommend everybody check this out.
And that's basically finished right now, or is that still call?
Yeah, this is now finished. This was the first year that we did this with we meaning the F# Software Foundation, not Microsoft. And we had pretty good turnout, so we're hoping to do this sort of thing sort of every year.
And so what does it mean? People basically submit projects, papers? Like what does it actually?
Yeah, there's a period of time where you can submit all sorts of cool stuff, and you do your best, and we have a set of judges who are considered F# experts, and they sort of, try to judge them based off of the categories that things are submitted in. And
many familiar names here on the.
Yeah,
that's awesome.
And then winners get announced, and they get like some swag, some stickers, that sort of stuff, and they get like a little certificate that says like you are a certified F# expert.
Nice.
It's pretty cool.
That is awesome. And I think the one thing you talked a little bit about was Ionide, right? Like I think most people who don't do F# probably never heard of it.
I've never heard of it.
Okay, so this is a Visual Studio Code plugin that has nearing 1.3 million downloads, which is pretty cool. Just dropped my wedding ring.
It's okay, you're already married. It's fine now.
It basically turns Visual Studio Code into a fully fledged F# IDE. And there's a whole bunch of features in there that don't exist, like for example in Visual Studio even, because it's also a bit of like an experimental ground for like what you can do with F# tools.
I see.
And some of that accrues to other editors, but it's the way that Ionide and Visual Studio work is it's very easy to move very quickly, and so that's sort of one of the purposes that it serves.
Sorry, I'm laughing because one of the comments says, chat is moving so fast no one will see I'm a Windows dev. I don't know why it cracks me up, but it does. And so this plugin is not written by Microsoft, right? This is basically a community project that
this is a community project, and it uses the same F# compiler and compiler service APIs that we use in Visual Studio. So like transitively, yes, Microsoft has like involvement in it, but in terms of like calling those APIs, building new features on top of them, and packaging it up and all that sort of stuff, that's entirely a community run thing.
So it's similar to OmniSharp, right? It's basically the F# experience of IntelliSense and I don't know, refactoring and other stuff for VS Code, right? Over the what's it called, the language server protocol?
Yeah, it now uses language server protocol. Well, it will. There's an experimental version of this plugin that uses it, and that's going to get moved over into the full version pretty soon.
I see.
That is cool stuff, man.
Yeah.
So
that's what I got.
That's what you got. That's awesome. That's more than I got. But that's what I brought Ahson on. So I don't have.
I mean, we could sit here and we could talk about counting inhabitants and types, and all about that sort of stuff that I learned last week when I was off at a conference. But I don't know if everybody else would be interested.
Excuse me, I need shots.
Inhabitants.
Before I can talk about higher order kind types, I need shots. I don't make the rules. I just follow them. So let's talk about JSON for a moment.
Sure,
so we have a new thing called System.Text.Json, right?
Yep.
So tell us a little bit about what it is and why we did it.
So System.Text.Json is the library that we have been working on, me and my team, which includes me, Steve Harder, and Jeremy Barton primarily. And this is a new library that we're shipping as part of .NET Core 3.0 that's driven primarily towards performance, driven towards supporting UTF-8 directly, and also driven so that it's built-in inbox, so there's no third-party dependency.
Right.
Including News.json, which is the most widely used JSON library in the .NET ecosystem. So one of the reasons, I think I heard this question in the chat as well, how does the new APIs relate to News.json? And so we went with a new approach that's built from the ground up, primarily because we wanted to leverage some of the new primitives that we included in .NET Core 2.1, for example, span and read-only sequence. And because News.json has a lot of features and a lot of users, their compatibility bar is really high. So making some of these performance optimizations was not really feasible in News.json.
Right. And when you say performance, like what does that mean? I mean, like everything that we have is that we did since .NET Core 1.0. Realistically, we try to make performance better. But what in particular are we talking about when we talk about JSON? Like what do we care about?
I mean, we talk about like high throughput, lower memory allocations, so that scenarios like SignalR or AceMinet's MVC have a lower memory footprint, and they can process your requests and responses much faster.
Right.
That's
so
primarily.
So it's basically for server for like high throughput when you have a gazillion requests a second basically, and so every time that you have a fixed cost like an allocation that goes on, like it just accrues to that check that you have to now pay for every request, right? Yep. And so in a world where we pay for resources and like specifically the cloud where basically you have to think about how many machines do you need to sustain your load, and if you can like reduce it by 20%, that means you can get 20% effectively savings in your number of machines you have to keep around. So I think we talked about this like last year, right? I think I just look at my announcement here that I published. This was from, I believe, October. So we talked about this openly for a while. So it hopefully people that are connected to us in the open source world, what we just talked about is not a complete surprise. Otherwise, we miserably failed at communicating. If you've never followed this repo, this .NET announcement repo is specifically designed for you to, keep basically track of what's going on. So we have like 91 issues. We never close issues in the announcement repo. So the idea is you can follow the repo, and you only get sporadically emails when new announcements are being posted, so that you're not drowning in notifications from GitHub, as the rest of us does every day. But the idea is that this way, basically, all the teams are publishing their announcements here. So if you haven't followed this yet, we post security updates here. We post feature updates, roadmap changes. Like everything that's relevant from an open source standpoint is what goes here.
Yeah.
If you're just curious about what's happening from the product standpoint, like just following our blog is also fine. But the blog is basically usually talking about things when things are either in preview or ready for release or something like this, which we basically do today for our JSON stuff, for example, right? But we are talking about this since October. So if you want to get a sneak peek early, you should really follow our announcement repo. Anyway, so the one thing that I wanted to mention here is you said like there's a bar problem with JSON.NET in the sense that there's a compat need, right?
Yeah.
And so this is not just us like making stuff up. Here's basically a quote from James himself, the author of JSON.NET. So since I don't know how many people know this, but we hired him. I want to say almost a year ago, maybe a year and a half ago. So James works for Microsoft now, so he may have a tilted view on this now as well. But I mean, the idea is, he maintained JSON for a long time, and it's not that we didn't try to like change JSON.NET, right? But the thing is, in JSON.NET is this what we call the Swiss Army knife kind of thing, and so it's very hard to like take new features like span of T that was designed for performance throughput and other things, and like retrofit this into the library without making either API or behavior breaking changes, right? Which we just couldn't figure out how to do that.
And also, at the guts of JSON.NET, it relies on strings, which are UTF-16 by default.
Right.
And by strings, I mean .NET strings. And we want to pivot a little bit and focus heavily on UTF-8.
Yeah. I mean, we've seen these other areas in the framework, right? I mean, we added overloads for span throughout the BCL. And there's areas where there's what's easier, where it's more logical. We already have an overload that takes a string, another overload that takes a byte array, we have another one that takes a span of byte now. But it's not always possible, right? Where you're like streams comes to mind here, where there's virtual methods, and it's very hard to like retrofit something span-based over that without making at least some sacrifices for perf somewhere. Right.
And it's also probably worth mentioning is because JSON has like a bunch of features, like you mentioned, and our library as V1 will not support most of the features.
Right.
It's primarily focused on narrowing down the scope of the problem, focusing on the scenarios that are most critical for cloud and web scenarios, like you mentioned, and optimizing for those. And that's part of the reason why we are in preview right now, is because we want to get feedback. So for vNext, we have a backlog of issues and features that people really actually ask for.
Right. So let's talk a little bit more about code.
Yeah.
So one thing that I'm always interested in is like when you look at JSONs, like serialization is this thing that happens on multiple layers, right? So like you can instantiate the reader and like mess with the braces yourself, but that's not how most people use it, right? So most people probably just use it as part of like ASP.NET, for example. So there's a little bit more like what's happening, what we see on the screen right now.
Yeah. So what I have is this is just a template that you get from .NET New if you want to create a new REST API. And if you see here, this is the sample that comes out with it, and the endpoint that I'm gonna hit is going to return a weather forecast. Now this is using JSON.NET under the covers to this was using JSON.NET under the covers to create your request and return the actual data back to you. Now what's happening in ASP.NET Core 3.0 since preview 6 is they have flipped the switch and now using System.Text.Json as the library that's driving this output. So I can show you what it would look like if I just run the web API, and let's see, let's target it. I'm just hitting localhost and see what the request looks like. So this response that came back is using System.Text.Json library. And one thing you can take a look at is like, is it using System.Text.Json library? Nope, it's not. It's using units of JSON. So the way I've done it is let's comment that out.
You probably need to add a semicolon or somewhere else.
Yes. So I realized when fields were being supported because fields is something that we don't support in System.Text.Json as for now. So okay. So this is the template that you would get. Ignore the commented out code. And if you were to rerun it, let's see.
Don't pay attention behind the for the man behind the curtain.
Yep. Fingers crossed. Okay. So let's clear the output. So this is using the System.Text.Json library under the covers. You see the output that temperature, date, and location. Now going back to the example I had, if let's say you for some reason your model had a field, which is something that we don't support, and you need to revert back to units of JSON, we provide this compatibility integration package called Microsoft ASP.NET Core MVC units of JSON, and you include the reference to this package, and in your service startup, you add units of JSON to your services.
So that's a key difference from before, right? Yeah. Like in .NET Core 2.2, right, the latest release before 3.0, like we wouldn't have had this line .add units of JSON. It was just implied that JSON.NET is the serialization library that we are using.
Yeah.
And basically we remove the dependency from ASP.NET. So if you just do the default, if you will, then you just get System.Text.Json. But with this line, you just bring back effectively the JSON.NET way of serialization.
So let me show you what happens if you didn't add units of JSON and if you happen to have a field.
Right.
So I just changed my model from a property to a public field, and what you would see is the temperature no longer showing up. Right? It used to show up and now it doesn't.
Right.
Now again, so if you want to go back and say, wait, I actually want fields in my model for some reason, you can add the units of JSON integration package, rerun it, and most likely you will get the temperature back if I did it correctly, which I did not. Semicolons.
It's almost like you want to use a language like F# that doesn't have semicolons.
Yep.
So actually, we do have semicolons, and depending on how you want to configure the parser, you can actually can turn off.
Did you just tell me that F# has semicolons? I'm holding onto this table. You're destroying my worldview.
I mean, you can do pound indent off, and you can create code that looks like a Christmas tree.
I heard what you said. I have no idea what it is.
You can make your code look like a Christmas tree in your text editor.
So you can win the the Perl obfuscation contest with F# submissions?
If you want to make Christmas trees.
That seems good.
Nice.
Anyways.
So going back to our demo, you see if you have fields, the temperature is back. And now my terminal is going crazy. Okay.
You just copy and paste the code. I see.
Okay, so that's on the ASP.NET layer. I also want to...
So the one thing I want to clarify, so it's not just fields, right? There's other fields, there's other features that we don't support that JSON.NET had support for. Can you give us some other examples of things?
Sure. So we have some of the things is like having support for octal. Like if you're reading a JSON payload and that happens to contain numbers that are prefixed with 0, JSON.NET assumes their format as octal and parses it as such. We assume that we follow the JSON RFC to the precisely. And that means we don't support octal numbers.
Right.
Other examples are things like custom constructors. So if your model had a custom constructor rather than the default parameterless constructor, we do not support that either.
So JSON.NET I think supports models where you have only get-only properties and then just a constructor with parameters, and they would just magically bind.
Yeah.
We don't do that, right?
Yeah. And then also JSON.NET supports a slew of existing and attributes.
Right.
We generally don't support all the attributes. We have our own attribute model.
Right.
Things like JSON ignore.
And are these things that we don't do for good, or is this things that we eventually want to plan on adding?
Right. So some of the things we don't do for good, like which is like, for example, if you have a request that you want to deviate from the JSON RFC by default, we wouldn't do that. But most things is something that's in our backlog of like, yes, we have considered it. We won't want to do in the future, especially if it's driven by customer requirements.
Right. But the idea was, I think, for us to like cut down the scope also to be able to do some proof optimizations, right? If we support every every possible feature in the world,
Yeah.
then effectively you reinvent JSON on every different API, but at the end it has the same problems, if you will, right?
Yeah. I mean, one thing that we do that's slightly different from JSON.NET is we support async APIs on the serializer at the top level, so that you can use a non-blocking I/O code.
Interesting. So basically, because we don't go through stream, is that the idea, or
No, so on the serializer, deserializer level, we have async APIs that accept stream.
Oh, JSON doesn't have any sort of async API? Oh,
yeah.
I see. Okay. Speaking about serialization, I think that's probably the next thing you want to demo a
So
little
I can
bit.
show you a sample of serialization. I can get my mouse working.
The chat is going crazy. Apparently, the Christmas tree comment really made people happy. Don't mind me just taking your semicolons for a walk.
Oh, I need to move the mouse closer to it.
Yeah, that was, I think, when you moved in and fixed your mic settings.
Okay.
I already like squeezed it in as much as I could.
Yeah. So if you can, I have an account model. It has email, create date, etc. And one thing that people do most often is they want to serialize their model, and then they also want to deserialize, right? So this is my helper method, just serialize. It takes an account, and if you look at my get account method, all it is new example account, filling in some fields. You have the email and a few things. So
I liked how you picked the name James by complete accident.
it just came to you for some reason. Okay, so
should have called him Jason.
okay, so if you were to run this, what we're doing is effectively taking the account model and serializing it as JSON, right? And this is not really human readable, so let's pre-print it. And the way you do it is pass options to the JSON serializer, and the options contains things like, do you want to support trailing commas? Do you want to support indented and non-indented? Do you want to have ignores, null values, etc.? And if you were to rerun it, it would be save. Yep. Okay. So it's more human readable now. Usually for performance, though, people tend to just have a minified JSON output because it has less. It's compressed effectively. And now on the deserialization side, which is if I had JSON payload coming in,
right?
What would that look like? It's effectively very similar to the serialization side, so just the similar code. Where instead of calling toString or 2 bytes, you just call the parse method on the serializer. These are static methods,
right?
And pass in the string that you have. In this case, we're just passing in the sample JSON string. Now, if you note here, this has a trailing comma, which usually, by default, trailing commas are not allowed in JSON. But if you wanted to opt into it, you would just set this as an option, allow trailing commas. And now we're able to deserialize.
So people are asking, what about comments? And somebody suggests you can just add a comment field to your JSON.
And now we have read the JSON string, and if you look at the sample code, here's the account, we're printing the email.
Right.
Regarding comments, you can ignore comments at the serialization layer, but it doesn't really make sense to allow comments, so that's the only feature that's supported. If you want to do that, you would just add, we have a thing called comment handling. It's an enum, and it's JSON comment handling .skip is what you want to do.
I'm amazed that you can just type this, but I guess that comes when you implement the feature.
Exactly. Now, so that's the most high layer of the stack, right? The serializer, deserializer. That's the people.
Yeah. So the one question I want to ask, because in the intro you mentioned that we are not based off of strings, but then in your code, the only thing I see here are strings. So how do I square these two statements?
So I use strings because they're easier to output to display as part of the demo. But effectively, for example, if you wanted to return a UTF-8 payload, we return it as a byte array, and you would change this to 2 UTF-8 bytes.
Right.
And that now returns a byte array, and this contains UTF-8 encoded JSON payload. And similarly on the deserialization side, if your JSON string was a byte array of UTF-8 encoded data, and keep in mind it has to be valid UTF-8, let's say, then again you pass that into the parse method.
It can also be a span, or can also be a.
That's right. So if you look at the parse APIs, we don't have an API that takes byte array. It takes a read-only span of byte, and there's an implicit conversion happening between byte array and read-only span of the covers. So yeah, you could totally pass in a read-only span of byte as well.
Yeah. That makes sense.
Yeah.
And so this way, basically, that's why we get the performance. It's just that these things are really useful when you have like something like a web server where you already have like memory allocated and stuff like that. But then, for things like this, when you just have a string in memory, you just want to party on that quickly. We also have those overloads. So while we don't optimize for convenience, we have some conveniences, so it's not completely writing assembler code.
Similarly, if you're like reading from a file stream, as long as it is saved as UTF-8, you can pass the stream directly. One question on the chat is, can we make the serializer strict? Yeah, so by default, if you do pass in no options, the serializer, deserializer is strict. So commas are not supported, trailing commas are not supported, comments are not supported, and basically whatever the JSON RFC states is what works.
Yeah, I think he cares more about the serializer part, where basically what we output is valid JSON, right? We don't output trailing commas ever.
Oh,
right?
yeah, exactly.
So like, I don't even think we have options for that, right?
Yeah.
Whatever we will produce is always 100% strict.
Yep.
So yeah, I think there's other questions that go further along the script, so maybe we should drop down a layer.
Yeah, so going down to the underlying reader and writer layer, right? We have what the serializer and deserializer is built on top of is the UTF-8 JSON reader and UTF-8 JSON writer.
Oh, before we go there, this guy forgot to ask this question.
What question?
You're representing F#. We're building a serializer. Do you have any concerns about that?
Yeah.
Would you mind sharing that?
The GitHub issue is filed. Yeah, I mean, there are two core types. Well, really three, but one of them is much like the first. There's F# records, F# anonymous records, and F# discriminated unions that kind of emit some rather complicated stuff for a variety of reasons, but yeah, I mean, that's sort of the primary data types that people use in F#.
Yeah, I mean, IL doesn't have discriminated unions, right? So you emit some types of some particular shape where...
It's like it's a sealed class with a bunch of other stuff in it.
Right. And so basically the question is, if you have an F# discriminated union, can we serialize that? And today the answer is probably no. I mean, you can probably serialize it, but we can probably not deserialize it.
Well, I mean, at least I would think that you wouldn't necessarily work off of the thing that is fully emitted, because we emit all sorts of stuff to make sure that things are structurally comparable and structurally equatable, and like that doesn't really matter for serialization. You're really like, okay, here's like a core shape of the thing. How do I like turn that into the string?
Right.
And then take that string and be like, okay, that represents a core shape that I can like call a constructor on and just do what I need to do. So
yeah, I think JSON.NET has some very advanced things, because basically everything there is built based off of reflection, right? So it inspects the types, and it even supports immutable types and many other things that we don't have right now. So this is on our list of things to do. For Theo, we just ran out of time to support this. If you follow our design reviews, it's hard enough for us to design serialization APIs right now. Like, we're not even in the mode where we're like, what if we have this completely other random shape of types that we want to support. But like, basically the idea is we plan on supporting that. Especially because C# also has a community union on their list of things they would like to support eventually. So
same thing with records. And well, so the way that they represent these things may be different, but it's sort of the core desire, basically.
Yes. Yeah, I mean, someone in this set mentioned, I think, Fuel Snable. Probably not. Either I pronounced the name wrong, or it's something I don't get the reference to. But basically, he's saying, or she actually, for that matter, whether we have extension points effectively, right? So other JSON libraries have extension points where you can basically plug in your own handler for whatever shape of types you have. That's kind of the thing that we're designing right now. Like, if you follow our YouTube the stream, but yeah. So the idea is we will have extension points. The problem with all these extension points is like how powerful are they? How complicated are they? But yes, I mean, if you're willing to write a lot of code, you can totally serialize anything you want. But things like F# discriminated unions or enums or some other things that have kind of built-in knowledge around certain things, you just expect to work eventually, right? And maybe we make you write one line of code to say, by default we don't because of perf, but you may have to write one line of code that's similar to the comment handling. You can just turn features on. All right, so then next layer.
Okay.
Let's drop one line.
Yeah, so the underlying primitive types that the serializer and deserializer is built on top of is the UTF-8 JSON reader and JSON writer.
Right.
And these types are effectively give you all the control that you want, right? drill deeper into, like, let's say you want to write comments, for example, or if you want to control exactly what the structure looks like, even if you want to write invalid JSON, you could do that using UTF-8 JSON writer. So I have an example here where I'm showing the JSON writer APIs, and you new up a JSON writer, you pass in a stream, or if you have an iBuffer writer, which is a new primitive we added in interface we added into one, which lets you control your own buffering. You pass that in as the output sync, and these APIs are similar to what we have in JSON.NET. You just call APIs like write start object, write string, write number, and since this type is disposable, you can just dispose it and it'll flush on dispose to the underlying output sync. In this case, it would be the stream. Now, if you notice here, we have JSON writer options. You can pass an indented true. The other option we have is skip validation, and by default we validate. So, for example, if you want to write start object and you write an array, we will throw in that case. But there's a performance cost to that. If you think that if you have tested your code, you validate that it's correct, and you want the JSON writer to get out of your way, you can skip validation, and now you can write whatever you want, and we will assume it's valid. So I would only do this if performance is super critical for you, and maybe even in debug, you keep this off, and release, you turn it to true. On the read side, we have, here's our JSON reader. Now this is a ref struct because it caches the underlying span. You pass in the data, and again, in this case, I'm using a byte array, but this is implicitly converted to a read-only span of byte. You pass in whether or not this is the last chunk of data you have, primarily because the reader allows reentrancy. You can pass in partial data and keep going, and you pass in the state. Now, if you have all the data in one byte array or as a string, and you're encoding in this, for example, in this case, its final block is true. You don't need to pass anything in the state; it's default. You don't need to do any state shuffling or management like that. And now we have the standard reader loop. You call reader.read, and you switch on the token type. Now, and per token, you have APIs like you want to get the string if the JSON string or property name, or if you want to get an int. Now, if you want to just showcase what it looks like, let's try to run it. So this is the output that we see when we write to the memory stream. We just wrote our date and temperature. This is what we are doing here. Write start object, write string, write number. And then now we're taking the same output that we read and reading it token by token. So if you see, we have start object followed by a property name, which is a date. And then we have strings, property names, number, and end object. Now, the interesting thing here is both reader and writer only support synchronous workloads. And what we've noticed is usually, especially on the right side, people generally write in synchronously, and then they do their actual either fetching of more data or any other processing asynchronously. And similarly on the read side, the process of the token by token is done synchronously. But if you want to fetch more data from, let's say, an underlying stream that you're reading a file from reading from a file or the network, you would go and fetch more data asynchronously and then pass that back to a reader. So I have an example for async writes. For example, you want to write a really large JSON string to a file, right? So we have this file stream, new have a file stream, some path to some JSON. And we pass this, and we're using the new C#8 syntax without braces. You pass in the stream to the JSON writer, and if you see here, we are awaiting it. So because we have a dispose async method on it as well. And you start writing JSON. Let's say you're writing 200,000, 2 million in this case, or 200 million instances of a JSON string. Periodically, what you want to do is flush to the underlying stream. Which is why we have this flush async method. And once you're done, you call write an array. And this effectively gives you the capability to write really large JSON, wrap asynchronous workload in a synchronous workhorse method. So the writer is doing synchronous work, and then if you want to go and flush, you can do async flush. Now we have the same pattern on the read side. The only difference is on the read side, since it's a ref struct, you cannot really new up the JSON reader in line with the method that is actually getting more data from the stream. You want to shuffle that off to a non-async method, because ref structs cannot survive across the async boundary, which is the main reason why we have this construct of state. So you fetch data from a stream, but let's say for example byte array, or you want to read from a pipe and you get a read-only sequence. you pass that to the reader with the state that you had previously, and you continue that loop to read more and more data. That's what it would look like.
Yeah, so basically that's kind of what we meant earlier with it's hard to retrofit these things over an existing API surface, because these are the kind of things that are just inherently different when you deal with async and span, right? Use the limitations of how span works. You kind of have to craft your types in such a way that these things are possible.
Yeah, so as an example on the read side, this is the API that the serializer uses to read from a stream. If you notice here, it has this loop and it's trying to read from the underlying stream, right? It gets the data and then it passes that in to this read core method with the state and whatever the data is, along with whether or not this was the last block of data that's been read. Right. And this read core method is what's new up a JSON reader, and under the covers actually deserializing and creating the .NET object that you want. That's pretty much it from my side. I wanted to call out a few people who have been working on the JSON stack, particularly community members. So recently, at least, and by the way, I apologize to anyone if I leave anyone out. But recently, we have people contributing from contributions from Vin, CPP, Your Deadfall, who actually implemented struct support, which we had scoped out for Trio, which is super awesome. And we have others like Christopher Watford. And also, during the initial design phase, we had community members like Ron Hoof, who was also writing a span JSON library on the side in parallel to the work we were doing. So his insights were also really useful, especially in the early design phase.
I think when we started, we reached out to everybody who we knew had a JSON library and like basically pointed them to the GitHub project and said, like, please provide your 2 cents. And I think the other thing that somebody pointed us to was there's a SIMD-based JSON reader as well, right?
Yeah. And we also be excited about that as well, because they're leveraging a lot of the hardware interfaces that came out in 3.0. Right. And we should definitely consider looking into that as well and incorporate some of the ideas into the JSON parser for us. That's something that we would consider for future.
That sounds awesome. So like there's one more thing I want to talk about. Let me just quickly jump to my screen here. So while you were talking, I was not paying attention because I was publishing a blog post. So
nice.
You fixed the WordPress?
I lost my life to WordPress yesterday. Now I just embedded the video and click publish.
When's the next time you're going to lose your life to WordPress?
I think it never stopped.
That's true. I feel the same way, actually. I feel like WordPress is just this endless suffering that we have to endure. Like, you know, there's something good going on in our lives, and like we need to balance that out by using WordPress.
See, this is how things work. Like as a developer, Ahson has to fight our build systems. As PM, he has to fight the WordPress. Like that's just.
Why can't we just have like, I want to be a PM who doesn't have to fight WordPress, or like I want to be a dev who doesn't have to fight build systems. Like, just write fun code and just write fun blog posts. Why can't we just do that?
I was about to say, like the PM position where you don't have to fight WordPress is called a developer. That's how we call it. So anyway, so the one thing in this blog post, like there's also a video in here, which by the way, I really would like to notice you one thing here. It's like, do you notice that we don't wear the same shirt today? That took effort. Like in this video, we failed that test. We both wear the same t-shirt. It's a good t-shirt, but no, we are not pizza boys. We are actually normally not wearing the same shirt. But anyway, so there's this thing here in this blog post that I want to quickly talk about, because we talk about performance a lot, and we can't really talk about perf without showing some numbers at least.
Right.
And so here, basically the raw numbers. You want to talk a little bit about what these numbers mean?
Sure. So effectively, if you want to use this serializer, deserializer on its own, you'll likely see a 1.5 to 2x performance improvement. And in the blog post, we share scenarios where the serializer is being used in MVC, and they see similar gains if they just do micro benchmarking of the serializer.
Right.
And end-to-end scenario, they see a 20% throughput increase by flipping to use our serializer, deserializer. The interesting thing that I really like is on the JSON document, even though it's read-only, we get almost up to 5x performance improvement.
Right. And
no allocations for reasonably sized payloads. So what we observed is usually for small payloads, people want simple and easy to use APIs, and they want a structured view of the JSON in .NET concepts and .NET entities. And if you were to build a dictionary or tree structure under the covers, it's massive. It allocates quite a bit.
Right.
What we did is build an in-memory database, and we enumerate the properties and things like that on query APIs, and that lets us leverage just a contiguous buffer, which we write from the array pool, so that therefore we can get allocation free for small payloads.
Right.
And that's where majority of the perf gains comes from.
Yeah, in-memory database sounds very very expensive, but basically it's just a bunch of indices in a byte array, right? So
Exactly.
it's not like we spin up some SQLite. Or,
Yeah. So when I say in-memory database, I'm talking about conceptually how I've envisioned the underlying representation.
But so Fuel Snable is asking allocation free is attractive, but compared to SIMD.JSON, but these numbers are compared to JSON.NET, right?
That's right, of course.
Do you have any sense for like if you look at SIMD.JSON, like how do they support, like how do they compare? Is it like 50% faster? Is it the same?
They're actually substantially faster. I think maybe 2 to 3x faster than even our library, at least on the reader side.
Nice.
I have not delved into deeply on like all the comparisons, but that's why I'm really interested in about how they do things.
That's awesome. So basically, these numbers there's still room for improvement.
Yes,
it sounds
for sure.
like
Exactly.
that's awesome.
Yeah.
Yeah, I think originally when I wrote the blog post, I said up to 5x faster, and you said you can't write this. This is too much promising. But like, yeah, I mean, we made it very clear. Like, you know, your mileage might vary. Like these are like, of course, micro benchmarks, right? So we look at particular things and we you know, basically scale them up and see where they land.
Yeah.
But I think the idea is that depending on what you're looking at, like, you know, MVC, for example, the numbers get slightly different because now you have more stuff from the stack running, right?
Yeah.
So like the more stuff you throw at something, like at some point you don't get as much perf increasement. But from our point of view, like the fundamentals matter, right?
Yes.
And so the more we can make the fundamental building blocks basically cheap,
Yeah.
the more we can give the higher layers effectively opportunities to make things slower by introducing like higher concepts that make things just more convenient without
Right.
paying a massive perf overhead, right?
I mean, like you mentioned, there's a lot of perf work still left to do.
Yeah.
And if you find scenarios, like if people who are watching find scenarios that performance is slow for you, please reach out. And also, I would gladly take contributions. In fact, I would encourage it. Like some of the people, like for example, the SIMD.JSON library, that was all open source contribution, right?
Right.
And it was based on C++, and it was ported to this C#.
Right. Yeah, I think that's the one thing I can't do with the blog, unfortunately. I can't take contributions with the blog. I have to write it myself. But the one thing that I want to also briefly talk about is how do I get the new JSON APIs? And there's basically two ways. Yesterday we shipped Preview 6.
Yeah.
So get the latest version of .NET Core Preview. That's basically what gives you the ASP.NET integration,
Yes.
where it ships by default. So one thing we really would like you to do is upgrade to Preview 6, your existing code base with your existing models, and run them through our serializer to see what falls over, right? Because for us, that's one of the harder things to measure. We don't know what your object shape looks like. We of course have telemetry for some things, like for example API usage, so we know which APIs are used a lot. We talked to James Newton King a lot, who authors JSON.NET.
Yeah.
So we have a lot of opinions on what we think is popular, but it's always helpful when people actually run into their code to see, oh, it turns out many people use immutable data structures, or many people would like to construct a thing working. Many people use fields. Like those are the kind of feedback that we're looking for to get. And then the other thing is there's a NuGet package as well. So System.Text.Json is also available on NuGet. It is as a .NET Standard 2.0 compatible library. So that means if you're on .NET Framework, even you can also use that.
Yeah.
But of course, you can't expect the same perf gains in .NET Framework because we depend on other things in the runtime that we have changed in core, around span in particular, that will make that faster. So the .NET Framework thing, I think, is mostly for you getting the programming model, but not necessarily getting the all the perf gains.
Yeah.
All right, so I think that's all I had from the JSON side. Is there more from the F# side? More about semicolons, the lack thereof.
I mean, there's always more from the F# side, but no, I think those are like the relevant. Well, I would say those are some of the top relevant community-oriented things on the F# side that I think are worth talking about.
Do you have anything now, or is it just like in general?
I mean, in terms of what we're working on, there's a lot of performance-related stuff that we're doing in the compiler and tools, and we're kind of sort of corralling all of the language work for a language release corresponding with .NET Core 3.0. That's kind of it. I mean, like, there's not a whole lot.
Does F# support string interpolation?
No, but I mean, we support type safe. Well, it's sprintf, so it's a function that you put in a format string, but it's tied in with a type system. So like if you say that something is a format specifier of type int and you pass in a string, you get a compile error. So it's more powerful than interpolated strings. Interpolated strings might land at some point in the future, but certainly not for the upcoming release, and it's not like on our priority list right now.
I like the little kick on the side.
But yeah, I mean, there's some stuff to talk about there, but it's like everything is sort of either in progress or like we haven't made the definitive decisions about what's getting cut or what's not. So I don't know if it's too interesting.
So when are JSON literals arriving?
JSON literals? Well, we already have type providers, so you don't need that.
Yeah. So the one question that came up here is JSON schemas. Right now, I don't think we have any plan for JSON schema, but it has come up before.
Yeah.
We're aware that it exists.
So JSON schema standard is still at like 0.6 or something like that, and it's revving really quickly. So we're waiting for it to stabilize a bit more and then get more requirements. And yeah, for sure, it's on our radar at least.
Yeah, we will probably provide something on top, like until that, because it's not something that the lower level has to support necessarily, right?
Yeah.
But I mean, similar to XML. If you look at XML, there's like a bunch of stuff that are layered on top of each other, right? It's just that the XML APIs are a bit dated at this point, but the general technology layering is similar, I think, to what we would do. All right, then I think there's no more questions in the chat, so that means we actually finish early today. We started late, we finished early. It's a good Thursday.
Let me give out one more shout out to Marco, who's also a contributor, who has helped in the JSON library. I missed him in the mentions.
That's sad. How is .NET Core 3.0 AOT compilation coming along? Is it the main roadblock for .NET Core UWP support, or are there other major items? So, Rich is probably the better way, the better person to talk about this. But the way I understand it is like the AOT compilation. So for .NET, so for UWP, we have this thing called .NET Native, which is basically a toolchain plus a compiler backend taken from C++ that basically does the whole enchilada of taking your C# code and emitting native code. This toolchain we would like to replace because that toolchain is fairly fragile at this moment. And so basically what we want to do is we want to move the whole UWP stack more or less to .NET Core, so that you can also use JIT-based runtime if you want to, because not everybody wants to pay the overhead of running AOT. For most apps, it doesn't even increase necessarily throughput by that much. It does a lot for startup, which we think we have other options to improve as well. And of course, we work with the Mono team on their AOT pipeline that we try to unify between what is in iOS and what we will do for UWP in the .NET 5 timeframe. So I don't think there's any major changes for Core 3.0 planned, as far as I understand it, though. When is applicative functor coming to computation expressions in Azure? I don't even know what that means.
I really wanted to just watch you try to pronounce that.
You want to link the blog? Somebody's asking in the chat.
Can I link the blog?
Go ahead and do that.
I don't even know how I can do this with this keyboard.
The applicative functor stuff, it's probably not going to be coming this year. It's like 75% there, but 75% isn't good enough to ship, and combined with other work that was higher priority, we just cut it. So I think we'll probably end up getting it sometime next year because it's really valuable to have. But
so what does it even mean? Like for people like me who are still a caveman and using C#?
There's a lot. There's a lot of things. I mean, it's kind of. Well, now we're getting into the monad tutorial problem, but where like once you know what this thing is, you can no longer like actually explain what it is. But at a high level, there are monadic operations you can do in F# today, which is a fancy way of saying computing within a given context. So in this case, say an asynchronous context, right? So within the type system, you can say, hey, there's a we call it an async block, and you can do async computations inside of that async block. You can await an asynchronous computation inside of that block, but you cannot await one outside of one of those blocks. It's very similar to C# like that. Right. But this is expressed more at the type system level rather than like, this thing where it's like a keywords that, magically turns into state machines under the covers like it is for C#.
Right.
So there are a few strategies that you can employ to kind of do what you want. One of the typical things is, I have this asynchronous call, I await the result. I have this other asynchronous call, I await the result. I do something with those things. Say one of those say an error happens, like something fails.
Okay.
So I fail to bind a result. it short circuits out and it says, all right, here's the failure. And so you can apply a particular type. We have a thing called a result type, where you can say, okay, there was either a success type or a failure type, and I'm going to associate that with the asynchronous call. All fine and dandy. But what if instead of short circuiting out on an error, you wanted to collect all errors and then have some sort of aggregate, some like aggregating function or something that you apply to all errors and then give that out. This isn't specific to errors, but this is just one example. You can't really express that well today in F#. Like you have to kind of go around. Like it's not that you have to go around the type system so much as the type system has like no way to sort of express that. So you have to sort of hardwire a lot of that stuff yourself. Right. Whereas an applicative functor is sort of saying it's within the context of this async block as an example, rather than having like effectively the full set of syntax available for you inside of that async block, you have a more restricted form where you have to express things in terms of, here's one call, and here's another call, and here's another call, and you have sort of like this set of things that get executed, like not necessarily in parallel, but you can imagine sort of conceptually in parallel. And they all sort of do their thing, and results come out of them, and you can do something with the set of results. So, and it's powerful because being able to tie that into the type system, first of all, it gives you nice syntax for doing this sort of thing, and second of all, buys you certain guarantees at compile time rather than runtime.
I see.
And it's helpful, but unfortunately, the work isn't quite there to support that.
So to just summarize what you said, monads are so 1990s. Applicative functors is the new monad. Is that a fair summary? I can't take credit for that statement. That's Fuel wrote this in the chat.
I think applicatives and monads were like discovered mathematically probably around the same time.
I have no idea. Like it makes sense what you're saying. Like what always amazes me with functional programming is that when somebody says, "I'm using feature X," and you hear what feature X is, it's like, "Oh, that makes sense." But the name that you chose for feature X, like unless you have a PhD in math,
that's one of the problems with monads, monoids, functors, applicatives, all that sort of stuff. Like they all mean things. And they have like a very mathematical meaning that you can. There's like an algebra applied to them that you can then encode into a type system. Because like unless you're just like basically just a total joke of a programming language, like every single programming language has like some sort of algebra or some sort of calculus, if you will, of types like baked into it, especially the type system. Like there's a lot of formalism there, and this is a way to extend it
JavaScript
further. Yeah, no, if you're JavaScript, it just mush it together and see what comes out. But like,
and it's always not a number, or it's null or not an object.
Yeah, but one of the problems is when you start getting into these sort of things where you're like, oh, I would like my type system to be able to express computation under a given context. And I want to be able to supply what that context means, but I want to be able to use the type system to enforce certain guarantees about that. That's effectively a monad or a monadic operations, but the word doesn't you can't hear that word without knowing what it is and be like, oh, I get it. That means contextual computations. Because the problem is it doesn't actually mean contextual computations. Monad it's an algebraic thing. And so it's math. How you use that math is kind of up to you, typically in the context of I want to compute, but I want certain guarantees about that. So, long story short, read up on monads. Read one of those monad tutorials that that's also the other thing. The monad tutorial thing is like a joke at this. It's like a really big meme at this point where everybody's like, oh, I learned what it is, so I'm gonna write a blog post that explains it. Right. And they always try to explain it by lowering the abstract mathematical concept into some like real world thing, and it makes sense for that thing. But then every single time somebody has a counterexample where it no longer makes sense, and the only way for that counterexample to make sense is you explain it in terms of the mathematical terms, not in terms of the concrete real world analog. And so then people are like, well, I guess this monad tutorial didn't actually explain monads because somebody came up with an example that violates what I just talked about. And that's that's typically what happens. So
I mean, what monads is for F# is what copy constructors are for C++, right? It all makes sense to a certain level, but it really doesn't.
I mean, I don't know. I think it's similar to covariance and contravariance. Like if you were to say that word to someone who never studied anything along those lines, they would be like, I have no idea what you're talking about.
I know what it is. I can never remember which one is which though.
Yeah, they're like contravariance. Yep. Okay, cool. What's the difference between co and contra? Like it's a similar sort of thing. So
two quick questions I want to answer. So one asked about my stickers on my laptop. Yep. I don't even know which one it is. It's probably
.NET Foundation.
I think this one is. I think you can. I don't even know whether you can order this one. However, there is a website called .NET/swag and the GitHub repo, where we have a ton of stickers that you can order. I believe so you can just download them and like, print them yourself. But I also thought at some point we had a link here to actually go to order stickers in our store. So there's a store you can actually order stuff from. There's a sticker pack you can order. Or you can just do what I do. You just find the people that distribute the stickers on Twitter and you harass them until you get one. That's my strategy. Unfortunately, you have to go to conferences to do this effectively because it's much more effective in person than it is on Twitter. Somebody else is asking, when will we be parsing JSON in Q#? And the answer is yes. I think that's pretty much all we had, I think, in question.
And I think Valby was asking for if, presumably, the JSON library, if they'll be available below Core 3.0 and will be as a NuGet package.
Below .NET Core 3 will not be available. No, it's available as a NuGet package for .NET Standard 2.0. So everything that supports .NET Standard 2.0 has access to the library. Yeah. There are issues for us with revving that API surface after we ship 3.0 due to the rules of versioning. Yeah. So the .NET Standard package is effectively, you can think of it as a bridge pack for the past, but it's not going to be this active developed components. If you want to get the latest features, you have to be on Core 3.0 moving forward. Post the link to the dev blogs. I showed it. It's basically our .NET blog. It's just the latest blog post. Yeah. You think I can just copy and paste the URL into the chat room? It's actually not that simple thanks to the computers that we have here. But it should be easy to find. So in that sense, I would say let's sign off. No, we're actually 2 minutes over. But hey, that is because somebody else was late.
We had a little divergence into monads. That's how we make sure we go over time.
That's true. We need a time-based monad to make estimates more accurate in the development of software. All right, then in this case, let me find the right button. Let me find the right button.
Cool beans. I'm gonna press one for you.
Okay, wave. Goodbye.
Thanks.
Goodbye.